The Aufbau principle says that electrons fill lowest energy levels first, lowest energy sublevels first. Well, let's look at this diagram to see the order in which electrons fill. The lowest energy level is n equals 1. The first energy level is closest to the nucleus and has the least amount of energy. There is only one sublevel in the first energy level. Its name is 1s. After the first energy level is filled, electrons go into the second energy level, or n equals 2. The second energy level has two sublevels. Their names are 2s and 2p. Within any energy level, an s sublevel is closer to the nucleus, which means it has the lesser amount of energy and will get filled first. In n equals 2, the 2s sublevel is filled first, and once it's filled, the next electrons will enter the 2p sublevel. After the second energy level is filled, electrons will enter the third energy level. The third energy level is made up of three sublevels: 3s, 3p, and 3d. The 3s sublevel will be filled with electrons before the 3p sublevel, and the 3p sublevel will be filled with electrons before the 3d. But be careful, because look at what happens next. When n equals 4, the 4s sublevel actually has less energy than the 3d sublevel. That means after the 3p sublevel is filled, the next electrons do not go into 3d. Instead, they go into the 4s sublevel. You will be able to refer to the diagonal rule in order to understand the exact order in which electrons fill. Now, in the beginning, it's easy. 1s, 2s, 2p, 3s, 3p. But now's when the confusion starts, because 4s gets filled before 3d. And what we're going to find out is that once we get to the fifth and sixth energy levels, there's a lot of overlapping, and that's why you can refer to the diagonal rule. Now remember, every sublevel is made up of one or more orbitals. All s sublevels have one orbital. Remember, an orbital is the region in which electrons move. 2 electrons can occupy each orbital. That means that an s sublevel can hold a maximum of 2 electrons. So we would write this as 1s2, 2s2, 3s2, 4s2. Now all p sublevels are made up of 3 orbitals, which means a p sublevel can hold a maximum of 6 electrons. Remember, 2 electrons can go into each orbital. These would be written as 2p6, 3p6, 4p6. All d sublevels are made up of 5 orbitals, which means that a d sublevel can hold a maximum of 10 electrons. We would write these as 3d10, 4d10. And finally, the f sublevel. The f sublevel is made up of 7 orbitals, each holding 2 electrons, which means it can have a maximum of 14 electrons. And we would wind up with 4f14. What we wind up with is this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Look at that 5s2 coming in there before 4d. Well, now let's look at the diagonal rule. This is the order in which subshells or sublevels are filled with electrons. First, we write our column of S's, then we put in our P's, then our D's, and then our F's. And we begin drawing in our diagonals. We go through the 1s sublevel first, then the 2s sublevel. After the 2s sublevel is filled, we go to 2p and then 3s. After 3s is filled, we go to 3p and 4s. After 4s is filled, we go to 3d, 4p, and 5s. 4d, 5p, 6s, 4f, 5d, 6p, 7s, and so on.